Here are the answers to the mental math. Give you some help if you need. Negative and a negative together, positive. And 144 divided by 6 is 24. I was just thinking 6 goes into 14 2 times with 2 left over, so 24 divided by 6 is 4, so 24 is what you get. All right, 1.5 times 4, so that's 4 plus half of 4, which is 6, times 10 to the negative 5, because negative 8 plus 3. This one, to think through a little bit, take away 1.5 from both sides, so you end up with 3.0. Well, 5 does not go into 3, so we know we're going to get a decimal. But 5 does go into 30, okay? So 5 times 6 is 30, so 5 times 0.6 is 3.0, okay? Again, what we do for converting is we divide this by 5, multiply by 9, and add 32. So 30 divided by 5 is 6. 6 times 9 is 54. 54 plus 32 is 86 degrees Fahrenheit. Okay, now we've got 6 times 2 plus 2/3 of 6. So 6 is 12 plus 4 is 16. This one's kind of nice. 10% more than 50. So 10% of 50 is 5. So we add that to 50 and we get 55. Okay, we're going to talk about something called probability, which I think we've already kind of discussed before. So we know the probability of getting a heads on a toss of a coin is 1/2, right? So we would say probability of getting a head when we flip a coin is going to be 1/2. All right, because you've got one shot out of 2 possibilities to get heads. Okay, so I'm going to show you, sometimes we might do 2 flips in a row, and we want to know what the probability of getting 2 heads in a row is, or a heads and a tails. So we're going to do what we're going to list a bunch of possible outcomes if we flip a coin twice. Okay, you can make a list of all your possibilities, but I'm going to instead show you how to make a tree diagram. Okay, so when we have 2 outcomes from our first event, we could either get a head or you could get a tail. So that would be your, event 1 or your flip number 1. Okay, then, so it's a tree, so you know this thing is probably going to grow. Okay, so let's say you got a head, and now you're going to flip again. And now you've got 2 more possibilities. You could either get a head or you could get a tail. Okay, or if you got a tail the first time and you flip again, you could get a head or you could get a tail. And so what we did was created a tree diagram, and by going through the paths, you can make a list of all your possibilities. So you could get a head and then a head, so we'd say H, H, or you could get a head and a tail, HT, or you could get a tail then a head, or you could get a tail then a tail. So it looks like our sample space shows us that we have 4 possible outcomes when we flip a coin twice. And here it is. Here's a list of all the possible outcomes. So like I said, what's the probability here of getting a head and then another head? Okay, well, looks like that only happens 1 out of 4 events. Okay, now here's a trickier one. What if I said, what's the probability of getting a different outcome each flip? Meaning, what if I get a heads and then a tails, or a tails and a heads? The flips are going to be different. So like we would say, probability of getting different sides after 2 flips. Okay, well, these 2 give us different sides of the coin, so it looks like we got 2 out of 4, or 1/2 of the time we're going to get one and the other. Okay, so the probability of, and we call these independent events, okay? An independent event means what happened on the second flip did not depend on what happened on the first flip. The first flip has no weight on what happens on the second flip, okay? And an example of dependent is if we were to draw a marble out of a bag and not put it back, if we mess with our sample space. Okay, let's look at some other options. Okay, so let's look at getting, without this tree diagram, let's say we do 3 flips. Probability of getting a head, and then a tail. Okay, well, the probability of getting a head the first time is a half. The probability of getting a head the second time is a half. And the probability of getting a tail is a half. Nothing affects each other, so it's always a half, right? So the probability of getting a head, and tail in that order would be 1/8. We multiply all the outcomes, okay? The book shows this a little bit in the book too. So it's hard to, these are harder to teach than it is to just do examples. So let's do examples. All right, here's the face of a spinner. It's divided into 4 congruent sectors. If it wasn't congruent, then it would give the advantage to one of the sections. Okay, so these are all congruent. What is the probability of getting a 2 on the first spin and a 1 on the second spin? Well, first we have to ask, does the second spin, does what we get on the first spin affect what we get on the second spin? No, it really, what happened at the beginning or what happened first does not change or even have any sort of effect on what could happen the next round. They are independent. So we're looking for the probability of getting a 2 and then a 1. Okay, so all we do is look and say, what's the probability of getting a 2? Well, it's 1 out of 4, 1/4. Okay, and then what's the probability of getting a 1? It's also 1/4. So your total probability is, multiply straight across, 1/16 is the answer to that, okay? Number 2 isn't so bad, then example 3 is very interesting. So let's look at example 2 first. We're going to look at Cecily, and she tosses a coin once, and it turns up heads. What's the probability she'll get a heads on the next toss? Okay, so we're asking, what's the probability of getting a heads and then a heads? Well, neither one affects the other, neither flip. So probability of getting a head is 1 out of 2. And then probability of getting a head is 1 out of 2. So her probability of getting a head and then a head is 1/4. Okay. And that goes with our tree diagram, right? Probability of getting, let's see if I can show you. Probability of getting a head and then a head is 1 out of 4 outcomes. Okay. This is example 3. A pair of dot cubes, or we call it a pair of dice, is tossed once. Okay, so you're rolling 2. What is the probability that the total number rolled will be 12? The total number when you add the 2 dice together. So what I did here is included a picture. Here are all the possible things that could happen when you roll 2 dice. You could get, double ones, a 1, a 2, all the way. This is the whole sample space, and I want you to look at how many outcomes are in the sample space. We've got 1, 2, 3, 4, 5, 6, by 1, 2, 3, 4, 5, 6. So there's 36 total when you roll a pair of dice. Now, I don't want you to have to draw this every time. If they ask a question, what's the probability? I'm just going to say probability of the sum is 12. Okay? You don't want to have to write this whole thing out. Now, here's another chart, and the book has one too. So dice A could get a 1, 2, 3, 4, 5, or 6 in dice 2. And in here is their sum. Okay, so you can kind of see where they get the sum of this one is 2, the sum of this one is 3, sum of this one is 4, and so on. Okay, so if you get a 1 and a 1, you get a 2. If you get a 2 and a 1, you get 3 as the sum. So the book shows this. It's a sample space of all the outcomes of rolling a pair of dice. There are 36, and that's a good thing to memorize. There are 36 total outcomes when you roll a pair of dice. Now, we're back to what is the probability that the total number will be a 12, okay? The sum will be a 12. Well, I look here, the only way to get a 12 is if you roll a 6 and a 6. There's one shot out of 36 outcomes that will give you a sum of 12 between your two die. Okay, so it's 1/36. Now, if they had said, what's the probability of getting a sum of 5? Then you would go, okay, 1, 2, 3, 4. 4 out of 36, which would be 1/9. Okay, so let's look at this one. With one toss of a pair of dice, what is the probability of rolling a total greater than 9? So what I write is greater than 9. Probability of getting a greater than 9. So now we look over here, and I look at all my greater than 9. So that leaves me these outcomes. And there are 1, 2, 3, 4, 5, 6 outcomes that would give us greater than 9 as the sum of the two together. So we've got, that would be 6 out of, like we said, 36 possible outcomes. And so 1/6 is the answer. Okay. Now, if events are dependent, when the outcome of one event affects the probability of the next event, the events are dependent. For instance, if a card is drawn from a deck and not put back, the probabilities of the draws of any remaining cards are affected by the first draw. And that's what they're saying here is probability of dependent events occurring in a specified order is the product, multiply, of the first event and then the recalculated possibilities of each subsequent event. Now that might have just been wah to you, so let's try and put that into practice. Okay, from a well-mixed deck of cards. Now I need you to know exactly what's in a deck of cards. I don't even know if kids play with cards anymore, but cards are going to be used a lot in any probability question, so it would be good for you to know. So there's a well-mixed deck of cards, meaning that it's not, if they're not shuffled, the probability is going to be weird. Avery selected and kept one card, then a second card, then a third card, and finally a fourth card. So she did 4 cards. She drew cards 4 times. What is the probability that the 4 cards Avery selected are aces? Now, you do need to know that every deck has 4 suits, and they go 2 through 10. Then you've got a jack, a queen, and a king, and an ace. Okay? So what that gives us is 2, 3, 4, 5, 6, 7, 8, 9, 10. And so that's 9, 10, 11, 12, 13. Okay? There are 13 cards, but then there are 4 suits. What that means is we've got, we have clubs, we have diamonds, okay, we have hearts, clubs, diamonds, and spades. Okay, and those are the colored cards. We have red cards, half of them are red. The hearts and diamonds are red, the clubs and spades are black, so half of the deck of cards is red, half is black, and so on. So we have 13 times 4 suits, so there are 52 cards is what you do need to know in a regular deck. Okay, so let's go back to Avery. She's going to select a card, and we want to know 4 times. What is the probability that 4 cards are aces. So probability of an ace again, an ace again. Now, if you are using your common sense right now, you might be thinking the odds of her getting all those is kind of crazy. It's not likely to get all aces in a row. Okay, so first shot is what's the probability of grabbing an ace? Okay, well, there are 4 aces. You know, there's an ace of clubs, an ace of diamond, an ace of heart, and an ace of spades. So there are 4 aces in a deck of 52. Okay, so that's round 1. However, we're going to assume she pulled a card and it was an ace. And so now we have 3 aces left to choose to grab out of 51 cards. Okay, then now there's only 2 aces left out of 50 cards, and then 1 ace out of 49. And we get the product of all those. As you can tell, this is going to be interesting because you got to do 52 times, or we can do some cross canceling. Let's do that. Okay, 4 goes into 52 actually 13 times, so we're going to do that. Okay, and then let's see, 2, where do we get the 17? Then we can say 2 goes into 50 25 times. Okay, and I guess 3 goes into 51. 3 goes into it, so 17 times. This is in the book too. Okay, so now we get to this point and we got 1, because we got 1 times 1 times 1 over, and it's okay, I'm going to use a calculator to show you this because we're going to do just a little thing with a calculator. Okay, so in order to figure out, we're going to go 13 times 17 times 25 times 49. Okay, what we get is the chances of getting 4 aces in a row are 1 in 270,725. And once you start playing with probability and seeing the probability of things happening, it makes you realize why gambling is not a good idea and is highly unlikely. Okay, you are much more likely to get in a car accident than you are to get 4 aces in a row. Okay, now the book talks about an exponent key, and I do want us to start getting used to calculators as we move forward in math. Learning how to use this tool is very important because this is real life. In real life, we get to use calculators. So many calculators have what's called an exponent key. On mine, this is my exponent key. It has a y to the x. Okay, so let's say I wanted to do 5 squared. I would do 5, the exponent key, squared equals, and we should get 25, right? Yes, 5, and that's the same as 5 times 5. So if I want to do 3 to the 3rd power, we should get 27, right? Okay, a lot of calculators look different, and so I think one of these days I'm going to have us all bring a calculator or work with a calculator in class. Okay, so let's say we are going to take a 10-question true or false test. What is the probability? So you got 10 questions and it's true or false, and you didn't study at all. You just wanted to say, okay, what are the chances? You know, I'm going to give you a little sample space here. I got 10 questions. What are the chances? And it's all true or false, right? What are the chances, or what's the probability of getting all 10 questions correct? Okay, so what we do is, let's say 10 correct. You've got 10 events, right? So chance of getting the first one right is 1/2. Chance of getting the second one right is 1/2. And third and fourth. And as you can see, there's going to be 10 of these for 10 questions. So this is where we could use our exponent key. When you multiply, what that is 1 over 2 to the 10th power. Okay? So our calculators can do some interesting things. So we can say, oh, well, what is 2 to the 10th power? I could try and do 2 times 2 times 2 times 2 times 2, or I can go 2 to the 10th power equals, and there we go, 1024. So the chances, or the probability of getting your whole test correct, if you guessed all those true and false, is 1 out of 1024. So don't plan on getting 100% if you didn't study and you were going to just guess all the true and false, because this is not a really good chance that you're going to get an A. All right, so let's look at where we were. Example 6. Find the probability of correctly guessing the answer to every question on a 20-question 4-option multiple choice test. Whoa. So let's look at that. Find the probability. So we've got 20 questions. So if we were to write this out, probability of getting all 20 correct. All right, so let's just see what this means. A 4-option multiple choice test. So let's just do the probability of getting the first one correct. So the first question correct, 4-option, be 1 out of 4, right? Okay, and the next one would be 1 out of 4, and we're going to have that 20 times. So 1/4 times 1/4, 20 times. So what that looks like is 1/4 to the 20th, or what that is, 1 to the 20th power. That's the same as just 1 over 4 to the 20th. Okay, so 1 to the 20th just means 1. All right, so 4 to the 20th power equals. Now we're going to get scientific notation, because that's so unlikely that we have such a big number down here, which makes this very unlikely. So 1.1 times 10 to the 12th. So when you have a fraction and the denominator is this large, it's a very small probability. In fact, it is less than 1 in a trillion. Okay, so when people say, yay, it's multiple choice, I'm just going to guess them all and maybe I'll get lucky, you have less than 1 in a trillion probability of getting all those multiple choice tests, getting them all correct. Okay, now it's practice time. That was a very long video for this. I apologize for that, and maybe we're going to deal with some of this in class. So those of you at home just had to sit through this whole thing. So I recommend turning this off and just using the solution manual, see if you did it correct. Okay, so go ahead and pause, turn this off, and then only come back if you need help on a particular problem. Okay, to win a game, Victor needs to roll a total of 9 with 1 toss of a pair of dice. So that's where we go back to that sample space of that picture, okay, where there were 36 outcomes. I lost it. There it is. So here's Victor, and this is what happens. And so he's got this, and we are looking for probability that he needs to roll a total of 9. So I'd say sum of 9 in his first roll. Okay, so we look here and look and see. Okay, well, the sum of 9 happens here, 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 and here. 1, 2, 3, 4 out of 36 outcomes. So I'm going to say 4 out of 30. 4 out of 36 equals 1/9. Okay. All right, draw a tree diagram looking like the one at the beginning of the lesson to find the sample space of 3 coin tosses. Okay, so we start out, you don't want to get too big or else it won't fit. So I'm going to say, all right, so we start out with, you could get a head or a tail. Okay, you can circle those. Then that would be flip 1. Now you're going to flip each one. You're going to flip again, not each one. You only have one. Head or tail. Okay, now that would be flip two, and now we're going to flip it a third time. So you could have gone heads, and then this one, heads or tails. Okay, head or tail, head or tail, head. I'm not very good at drawing these, or tail. Okay, so there it is. And what we'd write is you could get H, 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 an H, 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 T, okay, an H, T, H, an H, T, T. Okay, now, or you could get a tails, heads, heads, tails, heads, tails, 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 heads, or tails, tails, tails. Okay, so there, when you flip a coin 3 times, you got 1, 2, 3, 4, 5, 6, 7, 8 outcomes. Okay, and that's all we're supposed to do there. And now we've got Jasmine. She's taking a test, so we're going to see how bad her probability is. All right. She's taking a 4-option multiple choice test. There are 2 answers she does not know. If she can correctly rule out one option on one question, but no options on the other question, what is the probability she could? Okay, so we're going to say probability both correct. So we're just looking at 2 problems. Okay, so let's take out, she can rule out one option out of 4. So the first one, and now she knows that the chances of the 4 options. So what she knows, she has a chance of getting the right one out of 3. Okay. And the probability of the next one, but no options on the other question, so 1 out of 4 probability that she'll get the next one right. What's the probability she'll get both of them right? Is 1/12. So it's not a great probability when you don't know the answer. It helps when you can rule out an option or 2. Okay, let's say we could have ruled out 2. It would have been 1/2 times 1/2 would have been 1/4. So it helps to rule something out, gives you better probability. Okay, Quentin has a box containing a red marble, white marble, and a blue marble. Okay, so he has, we have to look at the page. So he has a red, a white, and a blue. Now these are tools and tricks they use in statistics classes in high school. Okay, so it's good that you're getting used to seeing this stuff. Okay, so here's red, white, and blue. Okay, and it says they showed, this is the sample space. So he pulled a marble out, put it back in, pulls another one. Okay, so he could get a red the first draw and a red the second draw. He could get a red the first draw, a white the second draw, or he could get a red the first draw and a blue. Okay, or he could get a white, then a red, a white, then a white, a white, and then a blue, and so on. You could get a blue and a red, a blue and a white, or a blue and a blue. So we just wrote out the whole sample space. So these are all the possible outcomes with drawing a marble, putting it back in, and drawing another one. Okay, and that is all we're supposed to do, is just show a sample space. And looks like there are 9 outcomes. They don't tell us to write that, but I just wanted you to see it. Okay, there it is. Sorry, long video. I'm just going to shut it off now.